Math 13 students. We have a little bit of discussion on a p-value or two. So follow me over to my screen. Yeah, 8.1 p-values. It's a probability. In other words, it's an area. So there's something visual to look at.
Wait, so you're saying the condition of the bridge?
Depends on a couple of things, the alternative hypothesis and the test statistic.
Look at that condition. I know.
If the p-value is less than or equal to alpha, we will go ahead and reject the null hypothesis. On the other hand, if the p-value is greater than alpha, we fail to reject the null hypothesis, which means we keep H null. Now, why is this so? A little bit of an example. We pretty much work exclusively within the Z distribution, although it applies to other distributions just as well. So there's my Z distribution. I've got a critical value set by the level of significance alpha. So alpha is that little bit of area right there. It's important to remember that alpha is area. Now, there's a couple of things that might happen. First, the p-value could be less than or equal to alpha. That means that my test statistic falls within the rejection region. So my test statistic falls there. And you'll note that that little bit of area in green is less than the shaded area in black. That area in green, that is the p-value. And here, the p-value is less than the alpha. That happens when the test statistic falls in the rejection region. On the other hand, it's possible that the test statistic does not fall in the rejection region. Now, if I compare the orange area to the black area, that orange area is the p-value. And you can see that that area is larger than the area in black that's set by the critical value and alpha. So if my p-value is bigger than the alpha, the test statistic falls in the non-rejection region where we'll end up keeping the null hypothesis right here. And again, if the test statistic falls in the rejection region, we'll go with the alternative. So hopefully that explains why we follow the rules we do. Now, let's take a look at an example or two where we actually find a p-value. So as I say, it depends entirely on the alternative hypothesis and the test statistic. So my first example, it's a right tail test. My test statistic, z equals 2.21. I think a picture is vital here. Remember, this is the Z distribution with a mean of 0 and a standard deviation of 1. And we are interested in this bit of area right there. That is the p-value. So we'll use normal 83 finds us the area, hence the probability. So I'll turn on my calculator. I'll find the normal 83 program. This is option number 1. 0 for the mean, 1 for the standard deviation. Greater than 2.21. And there we go. I'll remind people that we can take a look at a picture with this particular program. The p-value is a little bit of shaded area there. So we see that it's equal to a 0.0136. Capital P is the notation we use for the p-value. For my second example, a two-tailed test. By the way, the left-tail test is very, very similar. It's just over there on the left instead of on the right. So we've got a two-tailed test. I have a test statistic of a negative 1.71. So negative 1.71, we're talking about that little bit of area there. Let me bring some color into it, it's always better. Now, I'll use the same general program. I'll find this little bit of area right here. And that's the probability that z is less than a negative 1.71. So, my calculator. This is option number 2. Mean of 0, standard deviation of 1, negative 1.71. So I get a 0.0436. Now, in this particular case, we have a two-tailed test, which means there is a mirror reflection on the other side that needs to be brought into play. The area over here, positive 1.71, and I'm interested in this area here also. So it's really kind of a sum of these two areas. So I'll take that value there, and because it's a two-tailed test, I will double it. So the p-value for this example is 2 times 0.0436 or 0.0872. So there you have it, a couple of examples. The p-value for a one-tailed test, simple area argument. For the two-tailed test, I've actually got to bring in a second area there. I don't have to do any more work, but I do have to include that area there. And I do that by doubling the area on the left in this case. Thank you very much. I hope that helps.